everyone, we're going to evaluate the improper integral or state that it diverges. We're going from 0 to ln of 2. We have y to the power of negative 2 times e to the power of 1 divided by y dy. Now, this is improper because we have an infinite discontinuity at 0. And so it's continuous on 0 comma ln of 2. It can't be 0 because of this right here. It's undefined. So now we're going to, instead of doing our integral as normal, we're going to use improper integrals with infinite discontinuities and write it as a limit. So we're going to write this as the limit as b approaches 0 from the right, and we're going to change our 0, our lower limit, to b, and then evaluate that way. And that's going to be y to the power of negative 2, e to the 1 divided by y dy. Now we're going to have to integrate this, so let's let u equal this right here, which is y to the negative first power. So du equals negative y to negative 2 dy. So if you rewrote this just as a normal integral, this would be e to the power of u du. But if you change, we don't have a negative. So I'll put a negative here and make that positive. So this is going to be negative. All right, so that's your integration part. And we're going to write this as the limit as b approaches 0 from the right. And we're just going to get negative e. Substitute back in your u, which is 1 divided by y. And then we have, we're evaluating it from 0 to ln of 2. All right. So some of y'all can already see this, but let's substitute in and evaluate. So we're going to get negative e to the power of 1 divided by ln of 2. That's just the constant, minus a negative e to the 1 divided by, this should be b actually, b. Now when you evaluate this limit, as b approaches 0 from the right, what happens, this changes to a positive. This is going to go off to infinity. Okay, so because this is large, this is a constant. Because this is infinity, it doesn't matter what this one is, since that's a constant. So since it goes to infinity, this integral diverges. Thank you. Have a nice day. Bye-bye.